Hello dear learners, today I will discuss a simple example of line integration. As I have told you in my previous lecture, the line integration can be in 1D, 2D or 3D Cartesian coordinate systems. If we are in one-dimensional Cartesian coordinate system, then it is very easy for us, since in one-dimensional Cartesian coordinate r vector is also the function of x only and phi is also the function of x. So for 1D it will be very easy for us. Let's say phi x is equal to x. Now dr is nothing but I cap dx. So I can write down this integration as x dx. So as you know, integration of x is equal to x squared by 2. Now if you know the path, if the path is different, so if the it is there, find the line integral of phi x is equal to x from to b. Now if the initial and final points are given, so if it will simply go to 3, so it will be nothing but I cap into by 2 3 square minus 2 square 5 by 2 I cap. But if this function phi, if we just go to 2-dimensional, then also it is simple because phi is nothing but the function of x, y. Let's say it is 2x plus 3y. This is an x-axis. So it is a line going through the origin. Now, if it is said that what will be the line integration for point 1, 2 to point 2, 4. So how to find out the solution? So integration of phi here, it will be nothing but phi xy dx I cap plus dy j cap. X plus 3y dy. So now we will divide the integration into two paths, so we can choose our own path. So at first we will choose such two lines. So this is the path 1, this is the path 2. So we consider a third point C, which is nothing but the point 2, 0. So now we will divide the path in two parts. The first, so now we will do the integration for path 1 and path 2. So what is our path 1? In our path 1, as you see, sorry, I have written one thing wrong. This point is 2, 2. So what is our path 1? Our path 1 is AC, where x changes from 1 to 2, and where y is equal to constant is equal to 2. So in our integration, so I can define the first integration is I1. So I1 is equal to I cap. So you can put the value of y. So 2x plus 3 into 2 dx plus j cap 2x plus 3 into 2 dy. Since it's free, y is equal to constant. So this integration of second part vanishes. And the first part is equal to x is equal to 1 to 2. So we have to just find out the first part. So this is nothing but I cap into 2 into x square by 2 plus 6 into x from 1 to 2. So this is nothing but I cap into x square plus 6x from 1 to 2. This is 2 square is equal to 4 plus 6 into 2, 12 minus 1 square is equal to 1 plus 6 into 1, 6. So 16 minus 7, that is 9. So first integration is 9. So what is our path 2? As you can see, our path 2 is from C to B, where y is changing but x is equal to constant. So in our path 2, that is PC, y changes from 2 to 4 and x is equal to constant. What is the value of x? 2. So now if we define this integration as I2, you can simply put x is equal to 2. So what was our integration? Our integral was 2x plus, our integral was 2x plus 3y dx. So also here, since x is constant, the dx term will vanish, also the dy term will be present. So I will just write down the second part, 2x plus 3y dy. Simply dx is equal to 0 here. So and y varies from 2 to 4. Again I will put the value of x, which is 2. 2 into 2 plus 3y dy, and this value will be 4 plus 3y dy, where y varies from 2 to 4, and the integration becomes 4y plus 3y squared by 2, value varies from 2 to 2. And if you put simply the values, what we get? We get 4 into 4 plus 3 by 2 into 16 minus 4 into 2 plus 3 by 2 into 4. This is j cap. 16 plus 24 minus 8 minus 6. So this integration is nothing by j cap. So this is 10 plus 16. That means 26 j cap. So our final integration is nothing but I1 plus I2. That means integration from A to B, for path 1 A to B, and for path 2 B to C. So for path 1, sorry, here will be I cap. So it will be 9 I cap plus 26 J cap. So this is for a function with two coordinate system. This will be the integration in 2-dimensional. Similarly, in 3-dimensional, we have to choose our paths and we have to find out the line integration. Thank you for watching. In my next lecture, I will discuss phi of x, y, z line integration in 3 dimension.